Resotech, where resolution meets innovation. Within a consortium created to realize a project co-founded by the Eco-Innovation Initiative of the European Union, an open-source supervisory software called WSSC was developed to intercept and cut water leaks, reducing energy costs in water distribution. This was achieved through an effective monitoring system that serves to reduce leakage from the aqueducts to a minimum and facilitates repairs in case of breakage. This innovative system uses a number of Resotech sensors installed along the water distribution network. The sensor's data is analyzed and fed to the remote control system, where, on a map of the area, the points and orientations of water flow are established. This system has already been extensively tested in the Pisa district in Italy, with excellent results, and the area monitored has been broadened to extend beyond the city limits. The Resotech flowmeter bases its action on a patented innovative method which is used to measure hydraulic pressure. The force exercised by the water is read by a metering cylinder installed on the sensor, which is fitted inside the pipeline. Installing the sensor is a very simple operation and can be done without interrupting the flow. Installation of the device requires the application of a jack on which a special inserter is screwed. The Resotech flow sensor has been designed for flexibility, incremental deployment, scalability, coexistence and/or integration with existing measurement and control systems, including communication infrastructures. To insert the sensor in the pipeline, the lock ring on the inserter is loosened, and the metering device is inserted to the position in which the seal is guaranteed. The valve is opened and then closed again after letting the water enter the inserter chamber. Before positioning the sensor definitively in place, the elements of force must be reset to 0 so as to give the meter a null value. This can be done with a calibration software. After that, the valve can be reopened and the sensor pushed inside the pipeline to the required depth. The lock ring and safety cap can then be tightened definitively. At this point, the insertion of the sensor can be considered complete, and it will be possible to start to acquire and transmit measurements via a LoRa or NB-IoT data logger module. The Resotech flow sensor can optionally be equipped with an additional pressure and temperature sensor, so that 3 values are measured at the same measurement point. A cluster of sensors supplying the whole district make it possible to determine the amount of water being consumed with a simple in-out balance, and in particular, analyzing the amount of water moving through the pipeline at night. The data gathered by monitoring the minimum night flow is analyzed via a process of trending, which identifies potential new leakages. This works by comparing the previous night's data with current data over time, and enhances the ability to see new leakages and developing leaks, as well as the natural rate of rise in a system, and helps determine what the most economical intervention time or period is. The WSSC system continuously validates the data from the field, identifying any instrumental malfunctions in real time and ascertaining the validity of the balances calculated. WSSC Supervisor reads data via ODBC from SCADA, using standard protocols. In this way, WSSC Supervisor automatically identifies the malfunctions on the line and sends a brief message to the users associated with that district via text message or email. This message includes the type of event and its variation, the delta, district, date, length of time, the variable analyzed, and the current reference value. The system ensures efficient interaction between monitoring leaks and a rapid deployment of repair squads, which are actively supported by WSSC Supervisor when it comes to acting rapidly and with precision. The result of the operation should not be considered only as a mode of conservation of water resources, because WSSC also monitors the energy associated with the water flow and makes it possible to determine in kilowatt-hours the total quantity of energy wasted through the leaks. In many water distribution networks without an equivalent system, certain leaks could remain hidden indefinitely and never be identified. This system with Resotech flowmeters, the communication subsystem and supervisory software, comply with certification accreditation requirements of the European Technology Verification. Resotech can supply this flow sensor, optionally with a pressure and temperature sensor and the LoRa or NB-IoT communication module. The WSSC supervisor is not supplied by Resotech. The Resotech sensor is available as a product-as-a-service solution, which is especially attractive because it mitigates operational risks by including expert servicing and extended first-class guarantee. This solution contributes to sustainable business practices through a circular model, where, if necessary, the customer returns the product to Resotech, which can recycle the product and give it a new life. Resotech, where resolution meets innovation.